Hello everyone, welcome to the Science Stuff. Today we're gonna be learning about contact forces and the different types. So what exactly is force? Let's find out. Force is an external agent capable of changing the state of rest or motion of a particular body. It can also change the shape. It has a magnitude and a direction. Hence, it is a vector quantity. Pushing and pulling is an example of mechanical force. Here, we see a man pushing a tire and we see another man pulling a cart. Both of them are applying force. A force produces acceleration in a body. Hence, it moves with a change in velocity. Now, let's look at the different effects of forces. A force has two broad effects. The first one is that it can change the state of rest or motion of a body. Here, we see someone pushing a car from rest and making it move. A force can also change the state of motion of an object. Examples are a moving paper plane will eventually stop because of gravitational force and drag. A force can also change the speed and direction of motion. If a force is applied in any direction, then it changes both the speed and direction of the body. But if it is applied only perpendicularly, then it only changes the speed. Here we see a boy throw a ball. Hence he changes both the speed and direction because it is not going perpendicularly. But here we see a ball bouncing. And because the gravitational force applied is perpendicular, the motion only changes the speed and not the direction. The second effect of force is that when force is applied, change in shape or dimensions occur if it is a non-rigid body, because the interparticular spaces also change. Examples are kneading dough or making a clay pot. Here we see someone squishing a sponge and changing its shape by applying force. This can also fall under this category. Now let's look at contact forces. A contact force is any force that requires contact to occur. They are those forces that result from the interaction of two objects in physical contact with each other. Some examples of contact forces are muscular forces, frictional forces, normal reaction force, tension force, spring force, and collision force. Let's look at muscular force. This force is a type of mechanical force, and it is the force exerted by muscles of the body. All our body activities like lifting, walking, running, bending are because of muscular force. Here we see a boy pushing a block, and here we see another guy picking up grass. So in both of these, we are either pulling or pushing, and they both are using muscular force. Now let's look at frictional force. Friction is the resistance to motion of one object moving relative to another. It always acts in the direction opposite to the motion of a body. Friction occurs because of the intermolecular attraction between molecules of different surfaces when they are in contact. Friction often opposes the moving body, so it is also called a resistive force. Examples are a plate sliding. Here we see a book and a guy pushing this book. Then the frictional force will be opposite of the pushing force. The rougher the surface, the higher the frictional force. Now let's look at normal reaction force. An object on a given surface exerts a downward force on it due to the weight. For the object to remain in rest, an upward force from the surface is exerted on the object. This force is called the normal reaction force. Here we see a table and a ball on top of it. Now the weight of the gravity or the weight of the body is pulling the ball downwards. So the normal reaction force, the force exerted by the table on the ball, is pushing it upwards to create a balanced force. Let's look at tension force. The force that is transmitted through a string, rope, cable or wire when it is pulled tightly by the forces acting from the opposite ends is known as tension force. This force is always equal to the weight. Here we can see a plant strung from a wire. The weight or the gravity is pulling it downward and the tension force is acting upward to prevent it from falling down. Hence these two balance out the forces. If the string is cut, we notice that the plant moves downwards due to gravity, but the string makes a jerk upwards due to the tension force. Now let's look at spring force. The spring force is the force exerted by a compressed or stretched spring on any object that is attached to it. It works on the principle of restoring force, which restores it to the equilibrium. Here we can see a mass attached to the spring, which is at equilibrium. When we compress it and we leave it, eventually we notice that the force acts this side to get it back towards the equilibrium. This force is the spring force. When we stretch the mass, hence stretching the spring, we notice that the force acts to the left, trying to bring it back to the equilibrium position. So hence, we can see how it's trying to restore it back to the equilibrium. So these spring forces work on the principle of Hooke's law. This law states that the elongation of the spring in a spring balance is directly proportional to the weight suspended from it. Here we can see a spring with a mass of m, and when we double that m, we see that the elongation of the spring also increases. Hence, the length of the spring is directly proportional to the mass. The greater the mass, the greater the elongation. Now let's look at collision force. A collision force is defined as the force that is exerted on two bodies when they collide, which causes them to move apart from each other. So when two bodies collide with each other, the force exerted by body A on body B is equal to the force exerted by body B on body A. So let's look at it. So we saw that this ball moved forward, colliding with the other ball, and then both of them moved backwards. So here, this ball moving forward was the action force, and this motion was the reacting force. Thank you for watching this video. Please like, share, and subscribe if you've learned something new, and comment down below on the topic you would like me to do next. And you're watching The Science Stuff.